Hello everyone and welcome back to the course. Today we embark on a more complex journey as we learn advanced techniques of differentiation, starting by differentiating implicit functions. First of all, we start by defining what an explicit function is. We say that a function in two variables, g of xy equals 0, is defined explicitly if and only if this can be rewritten as y equals f of x. If the previous statement cannot be applied, then we say that the function is implicitly defined. For example, if we take the function x squared plus y squared minus 1 equals 0, this can be rewritten as y equals plus or minus the square root of 1 minus x squared. Therefore, we passed from a function g of xy equals 0 to a function y equals f of x. Thus, the previous example represented an explicit function. There are some functions that can't be explicitly defined. For example, the function x cubed times y minus y to the 7 times x equals 5. If we try to explicitly define it, that will be impossible. So the question is, how do we find the derivative of such a function? Well, what we do is that we assume the variable y as a function of x that we don't know, but we can apply the chain rule to. Taking into account the previous implicitly defined function, we are going to differentiate it. Now, the derivative of this function will be equal to the derivative of x cubed times y minus the derivative of y to the 7 times x equals the derivative of 5, which is equal to 0 because 5 is a constant. Now, the derivative of x cubed times y is equal to the derivative of x cubed times y plus x cubed times the derivative of y. And this, after simplification, will be equal to 3x squared times y plus x cubed times y prime. As well, the derivative of y to the 7 times x will be equal to the derivative of y to the 7 times x plus y to the 7 times the derivative of x. The derivative of y to the 7 is equal to 7 y to the 6 times y prime, and the derivative of x is just equal 1. Thus, the derivative of y to the 7 times x is equal to 7 y to the 6 y prime x plus y to the 7. Therefore, the entire derivative will be equal to 3x squared y plus x cubed y prime minus 7 y to the 6 y prime x minus y to the 7 equals 0. And we only need to solve for y prime. If we do so, we get the following derivative, and that will be implicit differentiation. Let us consider another example. Let us consider the function y times e to the xy equals 10. If we apply the derivative both sides, we get the derivative of y times e to the xy plus y times the derivative of e to the xy equals the derivative of 10, which is 0. Now, the derivative of y is y prime, and the derivative of e to the xy will be equal to e to the xy times the derivative of x times y, which is equal to y plus x times y prime. And we only need to substitute and rearrange, simplify, and finally solve for y prime. And if we do so, we get the following result, which is the implicit differentiation of the original function. That's it for today, guys. Right now, I want you to put your knowledge into practice for finding the derivatives of the following implicitly defined functions. So, see you in the next video.